Good morning, class. Let us now continue with the chapter The Triangle and its Properties. So, today we'll do exercise 6.4 and 6.5. So, let's begin. In the exercise 6.4, the main property that we'll be using is property of length of sides of a triangle. The sum of the length of any two sides of a triangle is greater than the length of the third side. And the second one, the difference between the length of any two sides of is smaller than the length of the third side. Okay? So basically, you should always remember that whenever you solve question related to a specific property, first you will have to quote the property and then go ahead with the next step. Else, marks will be reduced. Okay? So let's begin with the exercise 6.4. So let's begin with the first question. It states, is it possible to have a triangle with the following side? So you know the property. It states that the sum of the length of any two sides of a triangle is greater than the length of the third side, right? So you have to take the possible sides. For example, 2 and 3 first, add it, and then compare it with 5, then 3 and 5, and then compare it with 2, and then 2 and 5. And then compare it with 3. So let me show you the steps. Here, firstly, you will have to state the property. So it is already stated, right? The sum, since the triangle is possible whose sum of length of any two sides would be greater than the length of the third side, right? So that is already stated. And then now let's see the first part. Here the condition is given that the sides of the triangle are 2 centimeter, 3 centimeter, and 5 centimeters. So we state the property and check each possible side. That the first two case as the side as 2 and 3, then compare it with 5, then 2 and 5, compare it with 3, and 3 and 5, then compare it with 2, right? In this manner. But it is stated that in the first condition, that is 2 and 3 is equal to 5, not greater than 5. So it is not satisfying. So such a triangle is not possible. Now let us see the second one. Here the condition is given as 3 centimeter, 6 centimeter, and 7 centimeter. So we take each possible case and then we find this is satisfying all the 3 cases. So we can state the triangle is possible. Now the third part, that is 6 centimeters, 3 centimeters, and 2 centimeters. Over here, the third condition, that is when the side is 2 centimeters and 3 centimeters, it makes a sum of 5 centimeters, not 6 or greater than 6. So this triangle is actually not possible. So this is the way to solve the first question. Now let's move to the second one. The second question, take any point O in the interior of the triangle PQR. Is the 3 conditions possible, right? So let us solve this triangle, that is PQR. Okay, and we are drawing a point at the center, that is O. Okay, so this is O. Now what is happening is that there are 3 conditions that are given over here, that is these 3 conditions, whether it's possible or not. So we'll check it one by one. Okay, now let's go to the first condition. Is OP plus OQ greater than PQ over here? So where is OP? This is OP and this is OQ, right? Now we have to check whether OP plus OQ is greater than PQ. Okay, so is it forming a triangle? Yes, it is very well forming a triangle. So absolutely, if it's forming a triangle, the first the sides, that is OP plus OQ, should be greater than PQ. So it is, yes, it forms a triangle. So this condition is true. Okay, so we are firstly stating yes by telling that the condition is possible. Why? Because POQ is a triangle. Similarly, the second and the third conditions can be satisfied because RQR and ROP are triangles. So we can write the answers in the similar manner. Now let's go to the third question. Now the third question states, AM is the median of the triangle ABC. Is AB plus BC plus CA greater than 2AM? Now let's see how to solve this. Now this is the triangle ABC, right? And M is the median. So it divides the line BC into 2 equal parts, BM and MC. So in the third question, firstly we'll state the property. right? The sum of the length of any two sides of the triangle should be greater than the length of the third side. Therefore, we'll take the first triangle ABM and then state that AB plus BM should be greater than AM, right? So always consider we have to make this equation. So accordingly, we have to select the triangles in such a manner that both the side on the other side, that is this side, AM should come, because we have to get it as 2AM, right? So we are selecting the triangle AB as AB plus BM on one side and AM on the other side. Similarly, we'll select the triangle AMC on the, and make the second equation AC plus MC is greater than AM. Right? Now we are adding the first equation and the second equation. So the third equation we'll get it as AB plus BM plus AC plus MC is greater than AM plus AM. Right? Now next we'll get AB plus AC plus BM plus MC. So BM plus MC is actually BC. Right? So in the next one we can say AB plus AC plus BC is greater than 2AM. So hence we have proved the condition to be true. So always, if whenever you get such kind of question, see the equation, see the final equation that you have to make. So the final equation is such that in the right hand side 2AM is coming. So we have chosen the equation, the first two equations in the specified manner, such that in the right hand side AM comes. Okay, and then we have solved it and proved the same. Now let's move to the next question. The fourth question, it is a quadrilateral ABCD. And from there, you have to prove that AB plus BC plus CD plus DA is greater than AC plus BD. Now let's see how to solve this. In the fourth question, we have to consider the quadrilateral ABCD. Okay, so now here this is the quadrilateral ABCD, right? Over here it is specified that AB plus BC plus CD and DA, right? These are the four sides. Now we have to consider these four sides in the left hand side with the greater by sign, and then CA, that is AC, and BD should come in the right hand side. So always remember, we have to, in this kind of equation, of course the property that we have to use remains the same. So here we have to make the equations such that this is satisfied. So how can we do it? Now let us see. To solve this, firstly we'll consider the triangle ABC, okay, and then we'll say AC is less than AB plus BC, okay, right? Now next we'll take the triangle DAC, okay. Over here we'll say AC is less than DA plus CD, right? Now the third equation we'll make this, that is BDC. Over here we'll write BD is less than DC plus CB, right? And then the next triangle we'll take this, that is DB is less than AD plus AB, right? So here we'll get four equations in which AC and BD are coming on the right hand side. Okay, now we'll solve this. Let us see how. So now we'll write all the four equations that we found, and the next step will be to add the four equations. So after adding the four equations, we'll get something like this. So after adding, the next step we'll find that actually AB, BC, AD, DC are being repeating two times. So we'll write 2 into those on the left hand side, and AC and DB are repeating 2 times on the right hand side. So 2 will come on both the left hand side and the right hand side. We can cancel that, and our equation will be proved that AB plus BC plus CD plus DA is greater than AC plus BD. Similarly, in the fifth question, the same quadrilateral is being used, and in the left hand side, AB plus BC plus CA plus DA. So we are making a sum of some equations such that we get this in the left hand side. Right, now a less than sign is there, and on the other side AC has been added 2 times and BD has been added 2 times. Okay, now the equations have to be made in that format. So let us see how we can do that. Now to solve this question, what we'll do is, firstly we'll think about which all triangles we'll take such that AB, BC, CD and AD are on one side, right, and AC and DB are on other side, right, that is in front of greater than sign. So for that, what we'll do is like consider the 4 triangles as this triangle, this triangle, this triangle and this triangle. So these are the 4 triangles that we'll consider. Okay, and then make the equations. So first thing that we'll do is mark the point of intersection. So the point of intersection of AC and DB, we'll name it as O. Right, now the first triangle we'll consider as AOB, and make the equation as AO plus OB is always greater than AB. The second triangle we'll take it as BOC. Now in this BOC, what we'll do, we will make the equation as CB is always less than OB plus OC. And in the third triangle, what we'll do, we'll write CD is always less than OD plus OC. And in the fourth triangle, we'll say AD is always less than AO plus OD. Right? Now we'll see all these equations we'll add and solve and get the equation. Now let's see how to do that. Now these are the 4 equations that we got right now, right? The next will be to add the 4 equations. Now after adding the 4 equations, we'll get AB plus BC plus CD plus DA is actually less than 2 times OA plus OC and 2 times OD plus OB. Now what we'll do, we'll actually write it as 2 times AC plus DB, right? Try to solve the question by yourself. You will actually understand better, right? So open a rough book and try to solve it. It will be really easy. Now let's move to the 6th one. Now the 6th question, that is the last question of this exercise. The length of 2 sides of a triangle are 12 centimeters and 15 centimeters. Between what 2 measures should the length of the third side fall? Now in such kind of situations, what you have to do is you make use of both the theorems. Right? The first theorem, sum of the length of 2 sides of the triangle is greater than the length of the third side, and the second one that states the difference between the length of any 2 sides of a triangle is smaller than the length of the third side. Now let us see how we can solve this. Now this is the method we have to solve this. Firstly, we'll state the first property that the sum of the length of the 2 sides triangle should be greater than the length of the third side, and then find the sum, and we see that the sum is equal to 27. So we know that the length, the third side will always be less than 27. Right, now we'll find the difference. So here we find that the difference is 3 centimeters, and then we can say that the length will always be greater than 3 centimeters. So we know that the length of the triangle will be in between 3 centimeters and 27 centimeters. So this is the method to solve such kind of question. Now let us begin with the next exercise, that is exercise 6.5. So this exercise is basically based on the theorem, that is the Pythagoras property, where it states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of its length. So we can use this property, and let's see how to solve the exercise. Now this is the 6.5 exercise, but before going ahead, I would like to give you a quick revision of how to find the square root of a number. Because in this exercise, there are many questions wherein you will have to find the square roots to find the final answer. right? So let us do a quick revision of finding the square root using prime factorization method so that it will be easier for you to do or find the square roots. So let us take this example, that is 11,025, and we have to find the square root of this specific number. So let's find how to go ahead. But prime factorization is just one of the method. If you know any other method and it's the right one, you can use the same.
We know the rules of divisibility well. We can say that this number is divisible by 3, 5 and 7. So we can start with any prime number. Say 5. So 5 multiplied by 2,205 gives us 11,025. This number again is divisible by 5. Hence, we write a 5 here. And 5 multiplied by 441 gives us 2,205. Of course, you would take a bit more time to find the numbers here, but that's perfectly alright. And remember, we keep just the prime factors on the left-hand side. Now, since 441 is divisible by 3, let us write 3 here. And 3 multiplied by 147 gives us 441. This number is also divisible by 3. And 3 multiplied by 49 equals 147. And the only prime number 49 is divisible by is 7. And 7 multiplied by 7 is 49. And yes, we stop here since 7 is a prime number. So 11,025 can be written as 5 times 5 times 3 times 3 times 7 times 7. Hence, the square root of 11,025 can be written as square root of 5 times 5 times 3 times 3 times 7 times 7. The next step is to make pairs of the same numbers. And after we find the pairs, we choose one number from each pair. So we have 3 pairs here. A pair of 5s, a pair of 3s, and a pair of 7s. We choose one number from each pair. So from the first pair, we choose 5. From the second pair, we choose 3. And from the third pair, we choose a 7. And to find the square root, all we have to do is multiply these numbers. 5 multiplied by 3 multiplied by 7 equals 105. Hence, the square root of 11,025 is 105.
Now this is a table consisting of the square roots of numbers till 25. Make sure you learn them. It is always better to learn it because it really helps. Now let's begin the exercise 6.5. Here the first question says PQR is a triangle, right angled at P. If PQ is so much and PR is so much, find QR. So firstly we'll have to draw a rough sketch of the triangle, right? And it is specified it is right angled at P. So similarly we'll draw the triangle. So here firstly let's draw a rough sketch of the diagram of the triangle. So here this is the right angle triangle, right? Which is right angled at P. So P is the right angle, right? Angle P is the right angle, and PQ and PR, and PQ is 10 centimeters, PR is 24 centimeters. We have to find QR. So this is simple. We have to use the Pythagoras theorem, which states QR square is equal to PR square plus QP square. So let us see the solution of the same. So this is the solution. So firstly we'll write the property of the right angle triangle and then specify QR square is equal to PQ square plus PR square. Okay, now X is QR. So to find X, we find it as square root of 676. Now how do we find the square root of 676? Let me give you a quick recap of the same. So first step will be to divide it by a prime factor. So it is divisible by 2. So we'll write 2 here and we'll get the answer as 338, right? Now again it is divisible by 2 and then we'll get 169. right? So 169 is not divisible by 2 or 3 or 5 or 7. It is directly divisible by 13, right? So here we'll get it as 13. So here we'll get 676 can be written as 2 into 2 into 13 into 13. So we'll get the square root as 2 into 13, that is equal to 26. Okay. So in this manner, we found that the square root of 676 is 26 and we got the length of QR as 26 centimeter. Now let's begin with the second question. Here also it is the same as the first question because here we have a right angle triangle. Two sides are given and we have to find the third side. So we can say that the same theorem will be used to find the third side BC. You can try it for yourself. Third question is also kind of same. A 15-meter long ladder reaches a window 12 meters high from the ground on placing it aside a wall at a distance A. So from the wall, it is at the distance A. Find the distance of the foot of the ladder from the wall. So you have to find this A from the foot of the ladder to the wall. Okay. Now in the exam, this figure won't be given. So you will have to draw the figure by yourself and then solve the question. So then only you will be able to understand that this theorem has to be utilized and we have to solve this question, right? So here we know that the ladder is 15 meters, the wall is 12 meters, and the distance between the ladder and the wall. So that this is what has to be found, and here the property can be used. So we can write that 15 square is equal to 12 square plus a square, right? And then solve the equation and find the value of a. Now let's move to the fourth question. Which of the following can be the sides of a right angled triangle? Now in this question, there are three situations given. In the first question, it is 2.5 centimeters, 6.5 centimeters and 6 centimeters. So these are the three sides of a triangle. So always you should know that the longest one will be the hypotenuse. Right? So the equation that you will get over here is 6.5 square is equal to 2.5 square plus 6 square. So whichever satisfies the condition, right, that will be a right angle triangle. If this one satisfies the condition, this will be a right angle triangle. Over here 5 centimeter is the longest, so the equation will be 5 square is equal to 2 square plus 2 square. Right? Now, if it satisfies the condition, then it is a right angle triangle. Else, it is not. Similarly, the third part can be done. Now, the fifth question states, a tree is broken at a height of 5 meters from the ground and its top touches the ground at a distance of 12 meters from the base of the tree. Find the original height of the tree. Now, let us draw a rough sketch of the diagram of the fifth question. Now it is stated that the tree is broken at the height of 5 meters from the ground. So for example, suppose this is the tree, right? And here is the ground. Let us name it as B, right? And it is broken 5 meters from the ground. So here we'll name it as C, right? And we know this is the total height and this is A. Okay. Now we know what is BC. It is 5 centimeters. 5 meters. Okay. So you know BC is 5 meters. CA is the part which is broken, right? Now the next part which is given is that the top touches the ground at a distance of 12 meters. So this part is broken and this will come here, right? Okay, and this is the distance which is given to you. So you know this is 12 meters, right? And this is equal to this. So here A will come here. Okay, now this is the diagram. So here we have a right angled triangle ABC, where one leg is 5 meters, the other leg is 12 meters, and we have to find the length of AC. Simple. So here we have to use the theorem. So which will state AC square is equal to BC square plus AB square. So we'll get AC square is equal to 12 square plus 5 square. So AC square will be equal to 169. So we'll have to find the square root of 169, right? So we'll get AC as 13 meters, right? So the total height of the tree will be AC plus CB. So we can say the total height of the tree as 18 meters. Now let's move to the sixth question. This is really simple. Over here, angle Q and R of triangle PQR are 25 degree and 65 degree. 25 degree and 65 degree, right? Which of the following is true? So now look at this triangle. Here one angle is 25 degree, another angle is 65 degree. What is the sum of 65 plus 25? Sum is 90 degree, right? Now if this angle Q and angle R are 90 degree, the sum is 90 degree, and you also know, according to the angle sum property, the sum of the angles of a triangle is always 180, right? So if this is 90, then what will be angle P? It should be 90 degree itself. So if this is 90 degree, then what is the property of this line, of this triangle? In this, it will be, according to the property of hypotenuse, QR square will be equal to PR square plus QP square. Now in this, which one is satisfying the property? Here QR square is equal to PQ square plus RP square. Now this second one is the correct one. The rest of the two are wrong, right? Simple. Now let's move on to the seventh one. Now the seventh question says, find the perimeter of a rectangle whose length is 40 centimeters and the diagonal is 41 centimeters. Now let us draw a rough sketch of the seventh question. So here is the rectangle, right? The length is 40 centimeters. So over here, length is 40, right? And the diagonal is 41. Right. Now you know the length, and over here also it will be the same as 40. Now you don't know this, right? So what is the perimeter? Perimeter is equal to 2 into length plus breadth. So here suppose we consider this as x. Right now, what is the situation? You have two triangles, this triangle and this triangle, right? So if we just solve this triangle and find the value of x, we can easily find the perimeter, right? Now this is a right triangle because this is a rectangle, right? Now you know the equation, what it will be? X square plus 40 square will be equal to 41 square. So after finding the value of x, you can put the equation of the perimeter of a rectangle, which is equal to 2 into length plus breadth, and find the answer, right? So this is the method how to solve the equation. So here we will get 41 square will be equal to 40 square plus x square. We'll find x as square root of 81, that is 9 centimeters, right? After that we find the perimeter using the formula 2 into length plus breadth, and we get the answer as 98 centimeter. Now let's move to the 8th question. The diagonal of a rhombus measures 16 centimeters and 30 centimeters. Find its perimeter. So in a rhombus, there is a property which states that the diagonals of a rhombus bisect at 90 angle to each other. Bisect means it divides equally, right, at 90 degree. So we should use this property to solve this question. Let us see how. Now this is what is given in the question. So here is the rhombus, right? ABCD with diagonal DB and AC, right? In which one of the diagonal is 30 centimeters. For example, here AC is 30 centimeters and DB is 16 centimeters. Okay. Now the property states what? That the property states the diagonal of the rhombus bisected 90 degree angle to each other. So if this is a rhombus and these are the diagonals, now this angle will be 90 degree, right? So over here, they should bisect also. So if the point of intersection is O, then DB will be bisected at O, and OD and OB will be of equal length. So over here DB is 16 centimeters. So we can say that one side, that's OD, is equal to 8 centimeter and OB is equal to 8 centimeters. Similarly OC, over here OC, because AC is 30 centimeters, so OC will be 15 centimeters and OA will also be 15 centimeters. So you right now, if we consider this, right, so you know the length of OD, you know the length of OC, and you know it is making an angle of 90 degree over here. So you can find the measure of CD. So CD square will be equal to OD square plus OC square, right? So that will give you an answer as CD square is equal to 289. So similarly, we have found DC square is equal to OD square plus OC square. We have done the addition, and then we got DC square is equal to 289. So the square root of 289 is 17. So we can tell DC is equal to square root of 289. So we can see DC as 17 centimeters. Okay. Right, so we have found one of the side as DC. Now in a rhombus, all the four sides are the same. So the perimeter will be equal to 4 into one of the side, that's equal to 4 into DC, and we'll get 4 into 17, right? So the perimeter of ABCD will be equal to 4 into 17. That will be equal to 68 centimeter. So students, we have completed the exercise 6.5. If any of you have any doubt in any of the question, you can ask me. So students, we are done for today. Your homework is to complete exercise 6.4 and 6.5 in your notebooks. And also learn the square roots of all numbers till number 25. Thank you.